So looking at the groundwater management, past, present, and future in the Kings Basin, and I've got stuff on all three. So here's the Kings Basin for those of you who don't know where it is. It's in sort of the center of the San Joaquin Valley. It fits in 3 different counties, the majority in Fresno County, a bit down here in Kings, and some of Tulare County. It's some of the richest agricultural land in the world. And we grow a bunch of different stuff: citrus, vines, stone fruit here, some hay and grain crops. Down here, this is row crops, yeah. So anyway, lots of ag in the area. So let's look at the past, part 1. 1924 to 34 is the drought of record. And during that, we see, I can show you sustainability occurred during this drought of record in the basin at that time. We're going to see a drawdown, a recovery, and then I'm going to show you a sort of some stasis after that. This is an example of cyclic storage. If you think of sustainability, you don't necessarily want a flat line, but you can draw it down and then recover and use the aquifer up and down. But one of the things that's going to happen down here is that both the Kings and the San Joaquin River are major rechargers, but the San Joaquin River is going to change because of the Central Valley Project with time. So here's a look at the basin, San Joaquin River to the north, and the San Joaquin River is below grade for the area here. So most of the surface water delivery comes from the Kings River here. I'm going to have data for the Fresno Irrigation District and the Consolidated Irrigation District in the next slides. So here's a look at a hydrograph. The red is Consolidated Irrigation District, the green is Fresno Irrigation District, and here's the drought of record. 7 out of 11 years were dry. We draw down during the dry, refill in the wet, and there's a bit of stasis here after that. So we'll look at that. This has got quite a bit of data on it. What I'm going to do is look at the drought, the wet, the stasis, and sort of compare it to the average. So during the drought, precip at Fresno, about 2.5 inches below average. During the wet, a couple inches above average. During the stasis, a little above average. Kings River flow, it's important because that's the surface water delivery to the area. During the dry, we're about, call it 600,000 acre feet below, 600,000 acre feet above in the wet, and near normal during the stasis. Fresno Irrigation District, during the dry, dropped 7.2 feet, recovered 7.8 feet, and that stasis, it still dropped about 1.5 feet. Their deliveries, 100,000 below during the dry, a little bit above during the wet, and actually a little below average during that stasis. Consolidated Irrigation District, the next door neighbor, dropped 12 feet in the dry, recovered 10 or 11 in the wet, dropped 1 in that sort of stasis afterwards. What are they, about 90,000 acre feet below average in the dry, 100,000 acre feet above average during the wet, and a little bit above average during the stasis. So if I take a look, and these next numbers are, there should be a huge plus or minus on these next numbers. But during the dry, I've got to read this, and I don't have my glasses, so I can't see those. During the dry, the overdraft in Fresno was around 35,000 acre feet a year. During the recovery, it's something on the order of 103,000 acre feet per year. So we filled it back up. We had water to put back in there. Consolidated, 70,000 acre feet during the dry. During the wet, 162,000 acre feet. So we refilled it. So that's the cycle. So it was sustainable. One thing to keep in mind as this goes on with time is the population's increasing. Small numbers from these, but from 1940 to 50, it was 100,000 increase in population in Fresno County during that time. All right, so some things that happen next. This is the past part 2. So this is post-drought to 2012. The San Joaquin River is no longer online, or is no longer recharging, because that water is now Central Valley Project. It's going north and south on the Madera and Frank Kern canals. So that water not going down the San Joaquin River is lost to recharge for the area. We've got population growth, and along with that, water demand has gone up, and that's both human as well as the demand for food, which agriculture is giving you. So we've been unsustainable with regard to groundwater withdrawal, and there's two things going on here. It's dominated by those entities with no surface water entitlement. Two of them, one is the municipalities are principally pumping on groundwater, and then the other one is agriculture, and there's some ag that has no surface water entitlements. So here's a look, this is the Madera Canal going online in 1944. As it and the Friant Kern go online, San Joaquin River no longer gets recharge. So here's a look at the change in the water levels in this part two. So again, we see drops during the dry, some recoveries in the wets, but it's always been that the drops are greater than the recoveries. And where are we headed? We're headed down. So here's a look spatially on this. This is 1950 to 2013, 63 years of data. Two huge drops, one underneath metropolitan Fresno Clovis. It's about 160 feet. The other big, huge drop is out here in the western part of the area, and it's dominated in here by districts that have no title or entitlement to surface water. They're only on groundwater. And the big drop out here is about 180 feet in that 63-year period. So it's not just ag, it's ag and urban that are having these problems. Oh, I should back up one more thing. The areas that have title to surface water, their drops are less by quite a bit. Okay, so here's some statistics, and again, correlation does not mean causation, but there's some interesting correlations. This is looking at the depth to groundwater versus some variables. One of the better ones is with population. As the population increases, the depth to groundwater increases. Urban areas, as urban areas increase, groundwater declines. As ag areas decrease, groundwater decreases. That's the bit about ag is when you're flood irrigating, you're recharging the groundwater. Some other things, this is Raisin City here. It's the one that has no surface water. There's a very nice correlation between groundwater pumping and the decline in the water table in that area. When I get down to surface deliveries, Kings River flow and precip, there's lousy correlations between all of those. So some of this stuff looks like it's a bit anthropogenic here. So here's a look between depth to groundwater and population. As population increases, groundwater declines. Again, remember, there's correlation does not imply causation, but it looks like something might be going on here. The green, declining ag acres as the groundwater declines. The blue, increasing urban acres, the groundwater declines. Okay, so here's the present. 2012 to 16, we're in a race to the bottom. And the bigger entities are putting in big, huge, deep, expensive wells, turn the pump on, and we're drying out the small folks, rural residential, some smaller farmers, so that you are actually drying up wells. We have had basically no surface deliveries on a couple of the years, and you'll see that in a bit. And we've totally depended on groundwater for this, or not totally, but really heavily dependent on groundwater in the last 4 years. The other thing that's happening is we're shifting from annual crops to permanent crops, and that's being driven by economics that says you can make a profit on a permanent crop, you can't make it on a row crop. The other thing that happens there As you go to the permanent crop, you have higher continuous water demands. So here's some stuff out of the Kings River Basin annual report. And I can't read either of these without looking at the bigger slide here. 2014 to 15, the driest year on record on the Kings River, 361,000 acre feet, and the 4-year period, 11 to 15, was the 4 driest years on record on the Kings. 49% of normal, 40, 32, 21.5% of normal on the Kings River. If we look at San Joaquin, that's the Central Valley Project water. Some of the districts get a little bit of that, but a lot of it goes to other people. But here's some of the amounts that they were putting out. When you look at 14 and 15, absolutely 0% delivery on Central Valley Project surface water. So that's nothing coming in. It's got to be made up by groundwater. Again, out of the report, groundwater storage estimated to decrease by more than 1.5 million acre feet in the 1 year. And this is in comparison to the 64 to 15 average of negative 170,000. So almost an order of magnitude more than the average. It's significant. And if you look at the hydrograph, it's dropping out the bottom. Okay, some comparisons here. 24 to 34, that was a drought, about 165,000 acre feet of water withdrawn a year. Again, in the wet, we filled it up, so a plus 165. The long term, 64 to 2015, minus 170. Those are similar. I mean, the drought record and what we've been doing now is similar, the averages. The difference is I'm not refilling now, okay? I was refilling 24 to 34. This gives you an idea on part of that 170. It doesn't complete, but the big chunks are underneath Metro, Fresno, Clovis, where until 2007 they were totally dependent on groundwater for the city. And then in the west part of the basin where they have no surface water deliveries, again, a bigger chunk of it. So the future, we're in a critically overdrafted basin. Sigma says we've got to be sustainable. Currently, there's 6 GSAs forming. That may bifurcate to 8 in the future here, coming down in the last 6 months. We're going to have lower the water demand below our current use. That's both for ag and urban. Ag is going to wind up fallowing land, and we've got to recharge every bit of floodwaters that we've got. Again, we've got to try doing cyclic storage. We've got to refill in the wets what we take down in the dries. But that water that gets refilled in the wets, you can't have any new demand in that water because it's got to go, all of it has to go to recharge. You can't put new development, new ag on that water. You've got to recharge it. Okay, so here we are. There's our critically overdrafted basin. Here's our current 6 GSAs. The one right here is the area that has no surface water entitlement, and my guess is that that is going to go from currently 1 entity possibly to 3 entities. And the reason for the splits on these, it's the haves and the have-nots. FID, Consolidated, Alta, this lower area, they all have surface water entitlement. James also does, but this area has no surface water entitlement. And the guys that have are trying to get away from those who don't. And the GSA is going to be harsher on those who don't than those who have. Okay, again, a look at where the drops are beneath the city and in the areas that don't have surface water deliveries. All right, solutions. There's a lot of things that can go into this, but some things that you've got to consider. We're probably in the basin overdrafted by 14 to 15%. If the population stays constant, if the urban and ag demand stay constant, to be sustainable, we've got to cut out, the default is we've got to cut out 14% of irrigated ag to make it sustainable. So that's about 110,000 out of 775,000 acres. So it's not insignificant, it's not trivial. Now, if the population grows and the state says all counties have to make estimates of population growth in the future. And one of the ones that says, okay, we're going to add 1 million people by 2050. And again, if all I do is add the population and have constant ag and constant urban use, I then have to get rid of about 30% of irrigated ag in the area. Again, it's non-trivial. Also, one of the things that might happen in the future is that as you cut down water application, you're going to have soil problems. And then again, we got to recharge everything. So there's an infinite number of scenarios you can have to solve, you know, how do you parcel out the water, but here's some guesses based on numbers for me. The urban areas are going to have to cut their use by half, below 130 gallons per capita per day. Ultimately, I think it's headed where Australia is, 155 liters per capita. I think that's ultimately where it heads. If you have no surface water delivery, you went from 10 to 1. I didn't see the 5. Okay, non-surface, you've got to cut it by half, below 1.2 acre feet per acre. That means you're going to farm about 1/3 of what you've been farming. For the guys that have water surface deliveries, it's going to be below the current 2.7 acre feet per acre in the dries. You're going to have to max it out in the wets. Recharge, everything you can do, every way you can think of recharging, over irrigating, dormant irrigating, everything you can do. Recharge basins, ponds, wells, whatever, you're going to do it all. And the trick on that is we need a lot of infrastructure, but the recharge you can do for about 1/3 the cost of a dam and about 1/5 the time. The big trick is we get our floodwaters to recharge 200,000 to 600,000 acre feet in 90 to 120 days is what you've got to do it on, and you've got to do it real fast. Okay, there's recharge areas, recharge ponds, we've got some, recharge the ditches, over-irrigate, flood cropland. What's required? Stop, limit water demand, both urban and ag. Cut current water demand, work collectively to recharge floodwaters. Ag areas with no surface delivery are going to go fallow, or they're going to start farming solar. We've done some of the fallow or dryland farming, and solar is probably going to be the new stuff. And what's the future? Changes in lifestyle. Everybody's going to use less water, urban and ag both. And then the economy, there's going to be a higher cost of water to both urban and ag. And sustainable water means sustainable economy. And I think there's some limits to growth. And she says I'm out of time, so that's it.
Are the GSAs, are they hydrologically connected? And if so, is there some sort of overarching management for that?
Yeah, they're all connected. It's all one aquifer. It's all one. It's a sequence of coalescing alluvial fans, and they're all hydrologically connected.
So doesn't that then mean the GSAs can't come up with independent plans?
They're going to come up with independent plans, but what's going to happen is they have to. You have to work with your neighbors on water going in and out of each of those GSAs, and that's going to be a point of friction and how that pans
so
out.
You need some sort of overarching structure.
Well, DWR says you have to have an overarching structure for the basin, and all 6 GSAs or however many have to work on that. So there's going to be negotiation, conflict with that between the haves and the have-nots.